Hello, welcome to Econometrics Melody. In this video, we will discuss about the conditional probability. So in conditional probability, when we know the information about one event, then we use the information of that event in order to update the information or probability of the other event. So the understanding of conditional probability lies on understanding of the probability of AB. In how many ways can we write this relationship of probability of AB, that is A intersection B. So let us first assume that we know the information of A, and then we take this information of A and then we calculate B applying the information of this A. So this is equals to probability of AB, and first we know the information of A, this entire A, and then we are making use of that information in order to calculate AB, and we are taking from B, we are taking only what we know about A, so we end up getting probability of AB. Similarly, if we know the information of B, then we know about this B, the event B. Then after, in this event B, we are going to take only those informations from A that is related with B. So in this B, we are going to take only that information that is related with A. So it covers this region. Again, we end up with probability of AB. So from 1 and 2, what do we see? We see that probability of AB, this is equal to probability of A. First we know A, and then we update the information of B when we know A. Either this, or if we know B, then we make use of this information and then we find the probability of A. So from this relationship, we can say that probability of B given A, and if you concentrate up to this point, then we see that this is equal to probability of AB divided by probability of what information we know about A. And similarly, probability of AB, here we say that we know something about B, so this is equals to probability of AB and whatever thing we know about B, probability of B. So this is very simple relationship, and once we are able to express this relationship, then the conditional probability is not going to be that difficult. So in our previous video, we had said that two events A and B are independent. If we are able to write this relationship, probability of A intersection B or probability of AB is their individual product of their individual probability. But here in conditional probability, we are writing, so this is the case of independence. But here in conditional probability, we are writing AB. If we know the information of A at first, then we are using that information to update probability of B. So this is some sort of conditional probability. And in this case, event A and B, they are not independent. And similarly, the probability of AB, this is equal to, if we know the information of B, then we are going to use that information and we update the probability of A. So this is again the conditional probability. Now let us find the condition when the conditional probability, so when the two events are independent. If we compare them, the independence, condition of independence and conditional probability. So if we compare them, the first, let me call it AJ first, and then the one is another one is second, and this another one is third. And if we compare the first and second relationship, so we see that if we compare first and second, we see that probability of AB and AB, they are common, and probability of A, it is common. So we must get that probability of B should be equal to probability of B conditioned on A. So the unconditional probability, if it is equals to the conditional probability, then this is some indication of independence. Similar independence of the events A and B. Similarly, if we compare 1 and 3rd, what do we see? We have probability of AB is equals to probability of A into probability of B, but we have probability of B over here and we don't have probability of A. So if this probability of A is equals to probability of A condition on B, so if probability of A, if this is equal to probability of A condition on B, then again this will ensure independence. So when we generalize this to concept, we can say that if conditional probability is equals to the unconditional probability, then we can say that the two events are independent. So let us say the example whether that will be true or not. And first of all, let us start off with the conditional probability. So for any two events, we know that probability of A condition on B, how do we calculate it? We calculate it by using probability of A intersection B, and we divide it by whatever information we have about B. So if probability of AB, if we are able to write if probability of AB is equals to probability of A and probability of B, the product of their individual probabilities, then we have said that if the events A and B follow this multiplication rule, then we have said that A and B are independent. So let us apply this. If probability of AB, the product of the probability of AB, if we are able to express them in terms of the product of their individual probability, then what do we get? We see that this cancels out and this is equals to probability of A. So this is our conditional probability, and if we end up with their unconditional probability, then events A and B are independent. The same applies for probability. If we know something about A, then how do we calculate the probability of B when conditionally, when we know something about A? So this is again equal to, we start off with probability of AB and we divide it by probability of A because we know something about A. Now let us apply the same formula. If we are able to express the probability of AB is their product of their individual probability, so this is equals to probability of B and we divide it by probability of A. So probability of A and A cancels out, so this is equals to probability of B. Again, the conditional probability of B, this is equal to unconditional probability. So to sum up, we can say that if the conditional probability is equal to the unconditional probabilities for all the events, then we can say that the events are independent. And for this to, then the conditional probability is equal to the unconditional probability when we can express the intersection of their probability is the product of their individual probability. So this is the case of independence. So if this happens, then this will ultimately lead to equality of conditional probability to the unconditional probability. Now let us see an example. Let us say event A, it represents the ace of card, and event B, this represents the black card. Now we want to find what is the probability of getting ace if we know that the card we have drawn is black card. So our probability of getting ace is conditioned on this information that we have already acquired the black card. So if we apply the formula that we have just learned, this is equals to probability of A, B, and we divide it by probability of B. Here A is S, so A is equals to the card of ACS, and then B is equals to black. We have already told you these are the two events. And what is the probability of A intersection B? The S and B represents the card black. So AB, this represents the black S. So we have two black S, and then we divide it by the total number of cards, 52. So we are done with PAB, and we divide it by the probability of black. So what is the probability of getting black card? Probability of getting black card is equals to, there are 26 black cards and the total number of cards is equals to 52. And if we operate it properly, we say 2 by 52 into, we have 52 by 26, and if we cancel it out, so we get 2 1, and then 2 1 2, 2 1 2, 2 3 6, 1 by 13. Therefore probability of getting S if the card is black, this is equals to 1 by 13. This is our conditional probability. Now let us see whether these two events A and B, they are independent or not. So let us see. So let us calculate what is the probability of getting ACS card. So this is equals to, there are 4 S cards, and we divide it by the total number of cards, there are 52, and if we operate it, we get it as 1 divided by 13. This is our unconditional probability. So if we compare with the conditional probability, and that is equal to unconditional probability, so what we can say is the conditional probability is equal to the unconditional probability, then we can say that the events A and B, they are independent. We also know that for independence, probability of A, B must be equal to the product of their individual probability, and let us check whether this is true or not. So probability of A means probability of getting S, it is 4 by 52, into probability of getting B black card, it is just half of the cards are black, so it is 26 divided by 52. Therefore probability of AB is equals to 1 by 26. And what did we write in terms of probability of AB? Probability of AB here, our conditional probability. So this is also equal to 2 by 52. This is also equal to 1 by 26. And we found that the probability of AB, this is also equal to 1 by 26. Therefore, age probability of AB was equal to probability of A into probability of B. That is why we termed that the events A and B are independent. So let us quickly summarize what we have seen. Probability of A, B that can be written is in terms of conditional probability. First we know something about A, and then we use that information to obtain the probability of B. And in alternative way, if we know the probability of B, then we use the known information in order to update the probability of A. So either of the weight. Therefore, if probability of A condition and B, if we have to write it directly, first of all we take the probability of AB and we divide it by the known probability. And if we have to write the probability of B condition on A, if we know something about A, then we again take AB and we divide it by the known probability of A. And then therefore we can further expand it, probability A condition on B. So we know something about B and we can start off with probability of A into probability of B when we know A, and we divide this by probability of B. We are expanding this. So in place of probability of AB, here we know something about B and we are substituting A, the information when we know A. Similarly, the second one, probability of B condition on A, here we know A, so we start off with what we know of B, and then we update the information of A with respect to B, and then we divide it by the what we know about A. This is a simple relationship. For independence, this is the necessary condition. Probability of AB, when we are able to write probability of AB is the product of their individual probabilities, then in that case we get that probability of A condition on B should be equal to probability of A. We have seen that. And probability of B condition on A is equal to probability of B. To sum up, we say that the conditional probability is equal to the unconditional probability. And we have seen one example as well. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.